So welcome to the fourth of our series of videos where we're using MapSewer to create a catchment model within the Derby area. This is a fictional, I'd like to remind you. And in the first video we created the polygon subcatchments. The second video we created the pumping stations. The third video we added nodes, or we created some manual nodes, and then we connected those nodes together. And in this video I just want to show you how to export the properties of those nodes so that we can add sewer gradient, length and diameter information. And we can use the same principle for exporting pumping station data as well, and therefore re-importing it in a minute. So all you need to do is you go into export item to CSV, click on that button, and it generates a CSV file. And this is the one that it created. And so at the moment we've got the latitude, we've got the longitude, we've got the name of the sewer catchment, the nodes rather, and then we've got these fields here which are the sewer gradient, diameter and length. So all we need to do now is to populate those. So I'm just going to put some numbers in. So we'll add in a sewer diameter. That has to be in meters, so let's put it in as 0.15 and 450 meters of that. We're going to put that one as 0.09, sewer gradient diameter of 0.25, and then we'll add 300 meters of that, and I'm just going to 0.11. And we'll just create, I'm just going to create these as 0.35s, all of them. 0.4, 0.2. It's just so you get an idea of how it works, and let's just put some fictional lengths in. Oops, 150, make it a bit longer, and 3000. Doesn't really matter what they are, but I'm just going to save that file. Close it down. And I'm now just going to select my sewer nodes, import the file, which is that sewer node file. That file has been imported, and it will have showing now this is the previous file before it was updated. So now we've got all our data in. What this is doing will be calculating a snap to grid. As it processes through, it'll be snapping these diameter grids to a list of standard diameters that we've got, so it'll be updating as it goes along. So what we're now doing is, in each one of these, we'll now be converting the Q in into a Q out adjusted, so we'll actually be calculating the normal, what it would expect it to be flowing out of that sewer node, but then starting to adjust it for time of travel. So this will be the time out at the destination node. So what we've taken into account from this is our Q in, because it's a point, a Q in will be a Q out, so therefore our Q in and Q out adjusted will be different as we flow down the sewer. So we'll be attenuating the flow as we go down the sewer, and also we'll be delaying it and slowing it down. So that's the purpose of this particular part of the model, is to add in the attenuation properties of the time of transit properties of the sewer nodes. So we've now calculated that all, and that's all now being processed, and it will be delivered as it calculates through. So we can actually see in here that we're starting to get the snap to grids slowly starting to work. So 0.25 is snap to grid to 0.225, for example. So there's nothing else to see within the UI itself. The UI hasn't changed. I can just confirm that at any point you can, as in previous other videos, if we want to see what's happening in the video, we can go to Church Lane and we can select a point, and if we just, let's just say we want to look at it for a much shorter period of time, so just a couple of days, and that'll show us the Q out adjusted from that particular node. And if we go in, we can see that right the way through the network. So effectively that's what we're doing here, is we're showing and being able to demonstrate and calculate all the relevant data, and we can So a lot of this has been described in previous videos. So that's the end of this part of the video. In the next video we will be looking at other areas of configuration of the model when we're starting to get into the specifics of how we configure and validate the data. Thanks much indeed for listening. Bye.